Hi ma'am, hi classmates. Today, my report is all about domestic wastewater treatment. So first, what is domestic wastewater treatment? Domestic wastewater is the water that has been used by a community and which contains all the material added to the water during its use. It is thus composed of human body waste, example the feces, the urine, together with the water used for flushing toilets and salvage, which is the wastewater resulting from personal washing laundry, food preparation, and the cleaning of kitchen utensils. So, my content are introduction, wastewater treatment categorization, overview of wastewater treatment systems. We're gonna also tackle about the primary treatment, secondary treatment, the secondary clarification, the disinfection of wastewater, and the most important one is the sludge treatment and disposal. So, this my report is we're gonna know what are the we will also sorry my report is my report are sorry. So in my report, we'll also gonna learn what are the proper unit operation and processes used to be used. So the list of major objectives, also the list of major objectives. So first, the list of major objectives of domestic wastewater treatment. So the design engineer must know the influent wastewater characteristic and effluent requirements in order to select and design the proper unit operations and processes. We will select a unit operation and unit processes for treating the liquid wastewater and the residual or the sludge that is generated during treatment. The design of unit operation such as screening, grit removal, sedimentation, and disinfection is typically based on treating the peak hourly flow or known as the PHF. Unit processes such as activated sludge, BNR processes, RCBCs, and trickling filters are typically designed to treat the maximum month organic loading. We will select the chemicals for disinfecting wastewater effluent. So wastewater treatment categorization, there are secondary and advanced treatment. So designing domestic wastewater treatment plants requires knowledge of the influent wastewater characteristic and flows in addition to the effluent requirements, the proper selection of the treatment system. The treatment scheme that is selected will consist a series of unit operation and processes. A unit operation is defined as a physical treatment such as screening, grit removal, sedimentation, and sludge dewatering. Any treatment that involves a biological or chemical reaction is called a unit process. The typical unit process include activated sludge, trickling filters, rotating biological conductors or known as the RCBCs, membrane bioreactors or MBRS, chlorination, and phosphorus removal by a chemical addition. So, secondary treatment. Secondary treatment is the primary objective. The primary objectives of secondary treatment are to remove organic matter and total suspended solids and kill pathogens. In advanced wastewater treatment is a system that are those used for produce a higher quality effluent than can be accomplished with secondary treatment. AWT facilities are designed to remove nitrogen and phosphorus. AWT is the advanced wastewater treatment. And phosphorus through biological and or chemical means. Additional BOD5 and TSS removals beyond those achieved during secondary treatment are possible. So degrees of treatment. So in preliminary treatment, the purpose of preliminary treatment is to provide protection to the wastewater treatment plant. Equipment that follows. In some older municipal plants, the equalization step may not be included to prevent the introduction of pollutants into the wastewater treatment plant that will interfere with their operation, including interference with their use or with disposal of municipal sludge. So, in primary treatment, Primary treatment is the physical processes that remove non-homogenizable solids and homogenize the remaining effluent. The major goal of primary treatment is to remove from wastewater those pollutants that will either settle or float. So we'll go into secondary treatment. In secondary treatment, the primary is to the biological processes that remove most of the biochemical demand for oxygen. Although secondary treatment may remove more than 85% of BOD5 and suspended solids. So tertiary treatment, this process may involve chemical treatment and filtration of the wastewater. Physical, biological, and chemical process that remove nutrients like phosphorus, remove inorganic pollutants, and deodorize and dechlorize effluent water and carry out for further oxidation. So in primary treatment, there is screening and grit removal. So in screening, screens were the first form of wastewater treatment used by the communities and are used today as the first step in treatment plants. Typical screens shown in the next in my slide in my PPT. A screen in a modern treatment plant removes materials that might damage equipment or hinder further treatment. So in grit removal, screening is followed by grit removal. Grit removal is another unit operation that is normally performed during preliminary treatment and follows screening, so that inorganic particles as sand, silt, salts, small gravel, cinders, cigarette grounds, and eggshells are removed. There are two basic types of grit removal. Devices are aerated and vortex. So aerated grit chambers, the spiral roll of the aerated grit chamber liquid drives the grit into a hopper ring which is located under the air diffuser assembly. In vortex grit chambers, wastewater is brought into the chamber tangentially. At the center of the chamber, a rotating turbine with cone-shaped floor produces a spiraling donut-shaped flow pattern. So we're going to secondary treatment. In secondary treatment, we're also going to tackle about the activated sludge, aeration systems, and trickling filters. In secondary treatment, activated sludge. Activated sludge is the process is typically accomplished by biological means using microorganisms. So the microorganisms are the decomposer in ecological terms. That that use the energy for their own life and procreation. Secondary treatment process, such as the popular activated sludge system, are almost perfect systems. So, in activated sludge, as the microorganisms grow and are mixed the agitation of the air, the individual organisms clump together or flocculate to form an active mass of microbes or biological flock called activated sludge. The activated sludge process is controlled by wasting a portion of the microorganism each day in order to maintain the proper amount of microorganism to efficiently degrade the BOD5. So many modifications of the conventional activated sludge process have been developed to address specific treatment problems. A brief description of this is given on the next slides of my PPT. So there are many there are many there are many modifications. So the first is the conventional plug flow. Settled water and activated sludge enter the head and the end of the aeration tank and are mixed by diffuse air or mechanical aeration. Air application is generally uniform throughout the tank length. Next is the complete mix. Process is an application of the flow rate. A flow rate made of a continuous flow stirred tank reactor. Next is the aeration. Tapered aeration is a modification of the conventional plug flow process. Next is the step feed aeration. Step feed aeration is a modification of the conventional plug flow process in which the settled wastewater is introduced at several points in the aeration tank to equalize the food to microorganism. Next, the modified aeration. Modified aeration is similar to the conventional plug flow process except that shorter aeration times and higher food microorganism ratios are used. Next is contact stabilization. Contact stabilization uses two separate tanks or compartments for the treatment of the wastewater and stabilization of the activated sludge. Next is the extended aeration. Extended aeration is a process similar to the conventional plug flow. Next is high rate aeration. High rate aeration is a process modification in which high MLSS concentration are combined with high volumetric loadings. Next is the Krauss process. Krauss process is a variation of the step aeration process used to treat wastewater with the low nitrogen levels. Next is the high purity oxygen. High purity oxygen is used instead of air in the activated sludge process. Next is the oxidation ditch. The oxidation ditch consists of a ring or oval shaped channel and is equipped with mechanical aeration devices. Next is the sequencing batch reactor. The sequencing batch reactor is a fill and jaw type reactor system involving a single complete mix reactor. Next, the deep shaft reactor. The deep shaft reactor is a form of the activated sludge process. A vertical shaft about 120 to 150 meter deep replaces the primary clarifiers and aeration basin. Single stage nitrification. In single stage nitrification with BOD and ammonia, reduction occur in a single biological stage reactor. Separate stage nitrification. In separate stage nitrification, a process is used for nitrification operating on a feed waste from a preceding biological treatment unit. So those are the modification and the description of the conventional activated sludge process have been developed to address specific treatment problems. So we're back. So in aeration system, wastewater aeration is a process that occurs when air is added directly to wastewater, which allows for aerobic biodivision of any pollutants contained within. Aeration is an essential component of treating wastewater. So there are two types of aeration system. First is the mechanical aerator in operation. The second one is the diffuse aeration systems in operation. So in mechanical aerators in operation, mechanical aerators or surface aeration systems consist of mixers or brush rotors that transfer oxygen into the wastewater by spraying the wastewater into the atmosphere. So diffuse aeration system are similar to fish aquarium tanks in which oxygen diffuses through a diffuser stone or membrane, thereby transferring oxygen to the wastewater. Trickling filters. In trickling filters, an alternative biological process that was often used before activated sludge systems and and, and had gained wide acceptance is the aerobic attached growth process called the trickling filter. So in secondary clarification, if biological processes are to operate properly, it is essential that secondary clarifiers are be designed correctly for suspended growth systems such as activated sludge. Secondary clarifiers must be designed to accomplish both clarification and thickenings of solids. So when mixed liquor from the activated sludge process, it enters the secondary clarifier. Two process streams are produced. One is the clarifier secondary effluent and the other a more concentrated stream called the underflow. So clarification relates to the removal of suspended solids that entered the clarifier so that effluent standard can be met. So there are type of settling. The biological solids generated during secondary treatment and from processes such as activated sludge are flocculent in nature. Depending on the concentration, they will exhibit either type 2 or type 3 settling characters. So types of settling, there in type 2, settling involves flocculent particles at dilute solids concentration ranging negative 1 and ranging less than 1000 milligrams per liter. As these particles settle, the particles flocculate and they thus increase in size, causing them to settle at a faster velocity. In type 3, setting is called hindered or zone settling. It involves flocculent particles that at solid concentration ranging from 1000 to 4000 milligrams per liter. These flocculent particles are so close together that imparticle forces cause them to remain in a fixed position relative to each other and the mass of particles settle as a zone. So type 4, at high solids concentration when particles contact each other, settling can only happen if the mass of solids in the lower depths of the clarifier compress or consolidate. This is called the type 4 or compression settling, and the particles have only a slight velocity. So our next topic is solid flux theory. So the design secondary clarifiers are activate sludge process and gravity thickeners for processing sludge is based on solid flux theory as proposed by Dick of 1970. Batch settling column analysis must be conducted to obtain a limiting solids flux that is used in sizing the clarifier. According to Reynolds and Richards of 1996, present a graphical procedure for estimating the limiting of solids flux which is used to size secondary clarifiers. Batch or pilot scale is used to size secondary clarifiers. Secondary clarifier design for suspended growth system. As stated at the beginning of, of, of my report, proper separation of biological solids, secondary clarification to ensure successful operation of activated sludge or any biological process for suspended biological growth process. Both clarification and thickening of the biological solids is blizzard. The secondary clarifier design protocol requires calculation of the surface area or plant area of the clarifier based on clarification and also thickening considerations. Once the areas are calculated, the larger of the two areas controls the final design. So in secondary clarifier design for attached growth systems, the design of secondary or final clarifiers for attached biological growth system is similar to that for primary clarification. So for this situation, clarification of the wastewater is the main objective, whereas thickening is not biomass produced from tickling filters or biotowers. It's called humus, and it has settling characteristic similar to those discrete particles. So sludge that is collected in secondary clarifiers from attached growth system is often pumped back to the primary clarifiers or concentration with the primary sludge. Otherwise, it is removed from the secondary clarifier and pumped directly to the sludge processing facilities. So here in disinfection, the purpose of disinfecting wastewater is to kill an inactive disease-causing organism or pathogens such as bacteria, protozoa, helminths, and viruses. Wastewater must be disinfected in situations where humans may come in contact with it. Effluent from wastewater treatment plants is disinfected before it is released back to the environment, either discharged to a receiving water body or used for irrigation of crops, golf courses, or parks. So there are four methods of disinfection. First is the chemical agents. So why chemical agent? So the main chemical agents used include chlorine and its various forms, such as chlorine dioxide, bromines, NaCl, and NH2, sodium and hypochlorite, and calcium hypochlorite, along with ozone. So the next agent is the physical. Physical agents that are used include heat, light, and sound waves. Heating wastewater to boiling point is, of course, not practical. However, the ultraviolet radiation spectrum of sunlight is effective at inactivating pathogens. So mechanical means are those methods that remove potential pathogens from the wastewater as it passes through screens, grate chambers, or settling basins. Radiation, both ozonation and UV radiation offer the advantage of not having to remove chlorine if the effluent is discharged to surface waters. So proposed disinfection mechanism, according to Azano and others of 2007, there are at least 5 mechanisms that describe how disinfectants inactivate and kill pathogens. So the effectiveness of a specific disinfectant is primarily related to the targeted organism, for example, bacteria, virus, and protozoan, dosage of disinfectant, and contact time. The proposed mechanism are include the damage of the cell wall, alteration of cell permeability, the alteration of the colloidal nature of the cell's protoplasm, alteration of the cell's nucleic acid or the DNA or the RNA, inhibition of enzyme activity. So our next topic is all about the chlorination of wastewater. So chlorine is delivered to wastewater treatment facilities as a liquefied gas at high pressure in containers ranging in size from 150 pounds to 60 or 68 kilograms, cylinders through a 1 ton or 900 or more I 1 ton or 900 or almost to 1,000 kilograms cylinders all the way up to the railroad tankers, which may contain up to 55 tons or 49.9 meg or 49.9 mega megagrams of chlorine. Chlorine may be applied either as a gas or in aqueous solution. At most wastewater treatment plant, chlorine gas is dissolved in non-potable effluent which is then pumped to the chlorine contact chamber. Since chlorine is liquefied at high pressure, it may be drawn with the container either as a gas or a liquid, depending on the withdrawal rate. So chlorine contact basin is the generally consists of long rectangular serpentine channels to allow chlorine sufficient time to react with the pathogens. Solids and sludge sources and quantities of sludge. The primary source of solids or residual at wastewater treatment plant includes screens and gate chambers, primary clarifiers, secondary clarifiers, tertiary clarifiers, and digesters. The solids produced from screening the wastewater consist of paper, plastic, hair, rocks, logs, leaves, tree limbs, and other debris that must dispose at in a sanitary landfill. Grit chambers remove sand, gravel, eggshells, coffee grounds, glass, and bone chips. Typically, grit separators and grit washer are used in conjunction with grit chambers. Solids from grit chambers are transported to a landfill or disposal. Sludge mass volume relationship, where MS or mass of dry solids, mass of volatile solids, or mass of fixed solid. It is necessary to be familiar with sludge mass volume relationships when designing solids and handling and treatment systems. The specific gravity of the dry solids in sludge are important values to know. Typically, the specific gravity of volatile or organic solids and fixed mineral solids is assumed to be 1.0 and 2.5 respectively. Using these values and knowing the solid's content or moisture content of the sludge and the specific gravity of the dry solids, the specific gravity of the sludge can be determined. So we will go into sludge unit and operation and processes, sludge unit operations, and processing. The major goals of processing value, the processing, the major goals of processing sludge are to reduce the volume of the sludge, kill pathogen organism in the sludge. Three is to stabilize the sludge by furthering reducing the organic content and produce a product that can be used beneficially or safely to dispose. So the first is the sludge flow, then followed by thickening, then stabilization, then conditioning, then dewatering, then heat drying, then thermal reduction, then and it's free to reuse or to dispose. So in sludge thickening system, thickening of sludge is very important since it reduces the volume of the sludge to be handled, thereby reducing the size of subsequent solid handling processes such as sludge stabilization. Increasing the solids content of sludge from 1% to 3% results in a 67% reduction in the sludge volume. Gravity thickening. The gravity thickening of sludge is similar to the clarification and thickening of mixed liquor that occurs during secondary clarification, and it is typically accomplished in a circular basins. Sludge is fed to a center feed well and allowed and compact. Design of thickeners is based on solids loading rate and overflow rate. In most cases, the solids loading rate or the thickening rather than overflow rate or clarification will control the design. Recommended solids loading rates and overflow rates of designing gravity thickeners are listed. I have a schematic of a gravity thickener in my PPT. So we're going next to the gravity belt thickenings. So gravity belt thickeners or the GBTs are mechanical devices that consist of a fabric mesh belt that is moved over a series of rollers by a variable speed drive. So we're going to centrifuge. Centrifuge are used for thickening and dewatering sludge. Waste activated sludge may be thickened using a solid ball centrifuge without having to condition the sludge with polymer. So to improve performance, however, it is recommended that stand by polymer addition ecosystems by provided. According to Metcalf and ID of 2003, operational and maintenance costs can be substantial for centrifugal thickening, and it is only recommended for facilities larger than 5 mgd or 0.3 meter cube per second. A centrifuge uses a centrifugal force to speed up the separation of solids from the liquid to wastewater. So I have a schematic of a solid ball centrifuge on my PPT. So sludge stabilization. The objective of sludge stabilization are to reduce the liquid volume and quantity of a sludge solids to prevent nuisance odors and reduce the pathogen content. Aerobic digestion. Aerobic digestion is actually a continuation of the activated sludge process, operating in indigenous phase. Typically, waste-activated sludge is aerated for extended period so that microorganisms oxidize their own protoplasm since exogenous or the external carbon has been depleted. Advantages and disadvantages of aerobic digestion are listed. So, in advantage, one is volatile solids reduction approximately equal to that obtained anaerobically. 2. Lower BOD concentration in the supernatant. 3. Reduction of humus like biologically stable end product. 4. Recovery of the basic fertilizer value. 5. Ease of operation. 6 is the lower capital cost as compared to anaerobic digestion. Disadvantage: high power cost associated with aeration. 2. Digested sludge has poor mechanical dewatering characteristics. 3. Is process is significantly affected by temperature. 4. Cannot recover methane. 5. Generally, a lower solids content in digested sludge. 6. May have trouble meeting the Vector attraction reduction rule. 12 options available. Option 1 to 38% reduction in volatile solids is the most widely accepted option. Anaerobic digestion. Anaerobic digestion is the decomposition of organic matter and inorganic matter such as sulfate in the absence of oxygen. It is modeled as a three-step process: hydrolysis, acidogenesis, and metagenesis. So the two-stage anaerobic digestion, I have a two-stage anaerobic digestion in my PPT as schematic. So sludge dewatering systems. Dewatering is a unit operation primarily accompanied by mechanical means. The objective of dewatering is to increase the solids content of the sludge, thereby reducing the volume of sludge that must be handled. The major types of dewatering processors are commonly used to include centrifuge, belt filter presses, plate and frame presses, drying beds, and lagoons. So dewatering centrifuge. So the dewatering centrifuge are used for thickening and dewatering sludge. Centrifuge are primarily used for dewatering stabilized sludge or biosolids. So belt filter presses. Belt filter presses or the BFPs are similar to gravity belt thickeners. In addition to having a gravity drainage section for thickening sludge, a low pressure and a high pressure section follows where the sludge passes between two opposing belts. Next is the filter presses. Filter presses accomplish dewatering by forcing water from the sludge under high pressure. Sludge drying beds. Sludge drying beds are the most widely used common methods of dewatering sludge in the USA. According to Metcalf and Eddy of 2003, dewatering of sludge in drying beds is accomplished by two mechanisms. The main mechanism for removing water is through drainage and the secondary mechanism is through evaporation. So we have sand drying beds. Conventional and beds have been traditionally used for small and medium-sized communities. Sludge disposal. The sludge or residual that are generated during wastewater treatment must be properly disposed or, or recall that sewage sludge that has been stabilized and meets federal and state standard is referred as biosolids. Land application. Land application of biosolids is considered a beneficial use by the US EPA and is encouraged because biosolids contain beneficial plant nutrients, for example, nitrogen, phosphorus, and potassium, and soil conditioning properties. So other disposal method. First is incineration. Incineration of biosolid is actually a volume of reduction method. Since the remaining ash must be disposed of, incinerations are increasingly becoming more difficult to permit by regulatory agencies. Next is sanitary landfills. Screenings, grit, and share typically dispose with municipal solids waste in a sanitary landfill. Next is ocean dumping. Pumping biosolids through pipelines for disposal in the ocean or begging them out to sea for dumping is no longer practiced. So that's all my report for domestic wastewater treatment. Thank you po.